Now, I need some space here. I need some space to write. Let's use this PowerPoint because my fibers do not seem to work. Okay. No. Something you have to remember is C only compute the same data type. What I mean is that you have an integer I and you have a float f. Can you do I plus f? The correct answer is no. You cannot do the addition on an integer variable and a float variable. The answer is no. You cannot do this in C internally. Why is that? Why is that? Because they are not the same type. They are not the same data type. Okay. Similarly, to say is you cannot compare apple and orange. Okay. They are different things. Okay, you cannot compare dog and tiger. Okay. They are different breed. So, an integer and a float, they cannot do addition. They cannot add together. Syntactically, it's okay with C, but internally C will do something. What is the something C will do? Is do a data type conversion. Okay? What is conversion? It will internally do is, in this case, you want to plus I and F. You want to add I with F. Internally, you will change the data representation of I into flow. First, the first step, convert I in, I need space. I need space. The first step, convert, transformed, convert I into float. We spent many time, couple hours before, to talk about the data representation in float, in floating point, in integer, in ASCII code. So in integer, the way we say integer is different from the way we say floating point, or we call it real number. But a data type in cannot add with a data type float. So the way C do is you convert a small set into a bigger set mathematically sense. Okay? Now we know 1, 2, 3, 0, 1, 2, 3, or -1, -2, -3 is what? Is integer. But float, we can, in addition to this integer, float can be 1.2. In addition to integer, it can have a fraction part of the value. Okay, such as 1.2, 60.7, okay, 100.12, okay. In addition to integer value, for float, such a value can be saved in float. So this is a set we can use int to represent, but float kind of have a larger set. This for float. Okay? So the value can be represented in float kind of larger or include the value of int. Therefore, she will internally do is convert I into float representation. It will do this implicitly. It will do this without telling you, okay? Because the rule is that she cannot, or maybe our CPU cannot, do the computation of two different types. Okay? So an int cannot be computed with a float. So he will convert an int into float, and then the float representation of I will add with f. F is of course a float. So two floats will be added together. Okay? This is internally C will do. Okay? So now come back to our example. Our example is doing what? We are adding two integers together. We have the integer of D and the E. Okay? Then D is add with E, which is fine. It's very fine. No, not add. We divide. D is divided by E, and D is integer. And E is integer. Now, an integer divided by integer, which is very legal in C. But the result of two integers is also an integer. There's no way by putting two integers together and the result is not integer. Okay? So, numerically or mathematically, when you do 10, which is integer, in C's term, divided by 20, which is integer, in C's term, numerically, mathematically, the correct answer is 0.5. However, in C, the rule is the same type put together to do some kind of computation. The result will also be the same type. 0.5 is not, it cannot be represented as an integer. So what she doing is truncation. Means cut it off. Starting from where? Starting from this decimal point. the number after the decimal point is cut off. So when you do the cut off, when you do the truncation, 0.5 becomes 0, which is very sad. That's the reason we got here. This D is an integer, E is an integer, D is 10, E is 20. Divide do the division. The accurate answer is 0.5. But in C, integer computed with the integer, C will give you an integer answer. So 0.5 is not integer. So what she does is to truncate the number after the decimal point. So after the truncation, we got 0. Okay, so the result here is this highlight part get an integer result. Then we do the assignment, which is this equal signs. The integer part computation get a result of 0 and do the assignment to fraction. Even fraction is a double, which is capable of store much precise answer, such as 0.5. But you will not get 0.5 in fraction, in this fraction variable. Because in this part, we already convert, in this part, D over E. D is integer, divided by E is also an integer, and the result is integer. And since the result is integer, 0.5 will be truncated. So the answer is 0 for C. Then the integer C will assign to fraction, but even fraction is double. Okay? So when you execute this program, 10 over 20, you got 0.00. Okay? Now, let's try our example. Supposedly, we put, say, 20 over 15, 20 over 15. The answer is 1 point something, okay? What you get is 1.000, because after 0, after decimal point is truncated. Now, let's do more. 200 over what? 100. You will get a very beautiful answer, 2.000. Because in this case, there's no truncation happen. Because 200 over 100, the answer is 2. And the 2 assigned to a double variable fraction is 2.00. So this is much more comfortable. Yeah? Okay. Now, so what we can do in this case is that, did we say this example? Probably not. We say it in case we forgot. We say it first to get an accurate result. What we should do. Yes, 6 point A. Okay? Because we are going to have B pretty soon. So what we can do is so-called casting. I just want to say this word, cast. What cast mean is to do a type conversion. By programmer. Okay, or by user. How to do type conversion? It's very easy. Suppose you have integer I. Now you want to translate the I variable, which is integer, into floating point representation. What you can do is, before I variable, you put a small bracket, a parenthesis, and then put a type float before. Or you want to change the integer I into double representation. You just put a parenthesis and a double inside. All you do is transform the data storage method of I, which is integer formerly. Now you will change it into the storage method of double by putting this, okay? And in C, this is called casting. To put something in front of the variable. So I internally may be an integer of 10. After you put a double within a parenthesis before I, you can kind of look at this expression as what? As 10.0, which is no longer integer representation. It's a floating point representation of 10. Okay? It's a floating point representation of value 10. It contains a fraction part of 0. And it can do a much more accurate computation. So let's do cast in this example. D is an integer variable. Before we do this division here, we put a parenthesis and D will convert into a double representation, which is also a floating point representation. And then E, we also put a double in front of variable E. Okay? Then after this two conversion of D variable and the E variable, now we do this division. And this division is performing on two double variables. Okay? This one is double. This one is also double. So two double do the computation of division. The answer is double. And then we save into a double variable. So double divided by double, we get an answer of double. Then we do this assignment to double variable. So everything is double. Should be perfect. Okay? Now, after we do this small modification of program, we compile and link and we execute. Now, 10 divided by 20. All we got is perfect, 0.5. Okay? So, we say this as EXA, EX6 dash A V. Okay? So, now, detour a little bit from our PowerPoint. The question is how you find the nearest integer for a real number. Follow this line of discussion. How you find a nearest integer for say double variable or float variable. Say for example 1.4. The near integer, the closest integer is 1. 1.56. The nearest integer is 2. Just like something you learn from elementary school, so-called 45路. Okay? Okay? Everybody know what is it? 5.5. 五路. Okay? So this 5.5 becomes 6. 40. 5.4. You get 5. But here we change it a little bit. Instead of using this simple rule, we use closest integer. What's the nearest integer? If 1.51 is also 2, and 1.49 is 1. Okay, because compare for 1.49, compare 1 and 2, 1 is closer. Okay? So how you do this? How you can do this kind of thing? You get a floating point. Okay? Let's do an example here. Okay? Answer. Empty is the answer. Double. We will scanner. We're going to get a value. Ampersand value. So value is double. What formula we should use percentage LF. Okay? Now we can do a little bit of cosmetic. Is print input value is equal to what? The input fraction value. Okay? So before we run into scanf, we print some kind of message on the screen. it's kind of give the user a hint, okay, what you should do next, okay? It's going to do input fraction number, okay, and the save into double variable code value. Now, what we are going to do is supposedly the answer is integer. What you're going to find is bring the close integer is hot. So we are going to print two values. One is the value in variable code value, and the other is the integer called answer. And the answer is what? Is the closest integer of the double value stored in the variable value. And when you get the value, you get it through by calling the scanf. So what you should do? What you should do? You put the value here. Does it make sense? You put it this way. What she will do is get the value from variable of value. It's kind of confusing, okay? Let's change the variable name into var, okay? What she will do is take the value from var and it's going to assign the value into a variable called answer, which is int. What we will do is what? Is truncation. Because we have a double, which is likely to have a fraction part. Now we are going to say a data type called int, and int is a data type which does not allow fraction part. So you will do is just truncate the fraction part. So how we can deal with this problem? How we find the closest integer of var? Does anybody have an answer? Okay? Does anybody have an answer for my question? Please raise your hand. Okay? Plus 0.5. Okay? Because var is a double, and 0.5 is a floating value. Okay? We can call it a double. Now, to double put together, then we do the assignment. It will do the truncation. So we kind of increase 1/2 and then chop up the fraction part. And in this way, we can get the nearest integer of var that we input. So okay, so input a fraction value, or maybe a better way is a value. Anyway. Okay. 10.4. What's the closest integer? The closest integer of 10.4 is 10. Okay, so 4 is being truncated. Let's execute again. 12.401. Okay, what's the closest integer? It's 13. Because the fraction part is more than 1/2. Is more than 0.5. Okay, so we can use this to calculate the closest integer. And for this statement, we kind of take advantage of the internal conversion of C language. In my way of programming this stuff is that I will do the explicit conversion, which is also called cast. I will do cast because when we see this assignment, the right-hand side of the assignment is double. The left-hand side of this assignment is int. It's kind of mismatch between these two sides of the assignment. For programmers or for other person to take a look at this program, to have a clear picture of what this program will do, it's better that we do the explicit conversion cast. We put an int in before this computation. The result is the same, but it clearly indicates that we do a type conversion here. We intentionally convert double into int. So this is my way of programming. You clearly explain what it will do here. Even the result is the same. Without this test, without this parenthesis int, the result is the same. But I prefer put in parentheses, which will clearly state what's going on in this statement. Okay? So 21.50001. Okay? The answer is 22. Because this is still significant for double variable. Okay, so it's greater than 5. Okay, so it will kind of jump up to the higher integer of 22. Okay, and the program is the same. So we say it. How do we call it? We call it AC EX 6 AC. Okay. Now let's go back. Now for the example, let's go back this. Let's try to finish this chapter. Okay. So basically, this chapter is talking about scanf and printf, and this is what I'm talking about. We are going to guess 4 value. In fact, this 4 value can split among different lines. The value going to stop, going to fit, okay, going to fit into this 4 variable, but not necessarily put on the same line. They can split into different lines. Okay, so that's what I'm saying is scanf will keep looking for value, okay, until he got 4 value for this format. Okay, so new line will not stop. Okay, the scanf. Okay, now, so let's skip. Okay, this is what I'm talking about. Okay, you can use any character to be the spacer. Okay, to divide the two value. Okay, here we use backslash, and you can use blank. Okay, percentage D, blank percentage D, or you can use dollar signs. Okay, and percentage D and a percentage D. So when you input, you put a 10 and a dollar signs and a 20. Okay, and this kind of input will match this format. The spacer is dollar sign. Okay, so now this printf, you are not supposed to put to ampersand before the variable. This is wrong. Okay, so this point I emphasized in the previous class. So it's kind of confusing, printf and scanf. And for now, you just remember scanf, you mean ampersand. Okay, printf, you don't mean ampersand. Okay, for now, just remember. And later, when we talking about address and a pointer, you will be really clear about what's going on. Okay. Now, this is the example. Okay, more complicated than we just use, but the idea is the same. Okay, so it's nice we finish this chapter 3. Okay? 5 minutes away from the end of this class, so we got 5 minutes left, and I have no intention to go to chapter 4. Question? you guys will get this example from EE class, and also the assignment for today, and I mean for this coming week. So by the end of today is Thursday. By the end of the next Wednesday midnight, okay, you should turn in your assignment on EE class, okay, and the assignment will give you sometime tonight, and or tomorrow morning, the latest, okay. And you have about 1 week, less than 1 week, to finish the assignment and turn in your assignment in EE class. Okay. After Wednesday midnight, okay, no assignment will be accepted. Okay, no assignment will be accepted after Wednesday midnight. So you have to finish before next Wednesday midnight. Okay. So any question? Any question? Okay. So if